Hey guys, Sukani here. In today's video, we're going to be taking a look at how we can solve this tricky integral, integration -1 to 2 of absolute value of x plus 1 plus absolute value of x plus absolute value of x minus 1 dx. And whenever I say absolute value, I always know that I have to break it apart into a piecewise function. So we have to do that for each and every single one of these absolute value expressions. So let's start off with the first one. Let's start off with x plus 1. And I'm going to break this apart into two expressions, essentially. One x is greater than -1, and the other one x is less than -1. Now you might be wondering, where did I get this -1 from? Well, I wanted to find when this expression crosses the x-axis. I know this is just a line. I set x plus 1 equal to 0 to see when it crosses the x-axis, hence x is equal to -1. So that's how I got that -1 from there. Now, we have our ranges, but what is the actual expression? Because they're going to be two different expressions based on the domain. Let's think of the most simple example. When x is greater than -1, our new expression is just going to be the exact same thing, x plus 1. And this is because let's take a number greater than -1. Let's say we take 2. So if we take 2 and we plug it into this expression, we get 2 plus 1, which is 3. And if we plug in 2 in here, we get 2 plus 1, which is 3. So this 3 and this 3, they match. And that is exactly what we want. But remember, this expression is only true when x is greater than -1. When x is less than -1, our expression is going to be -x plus 1. And the reason for this, we can substitute values in again. Let's take a value that is less than -1. So let's say x is equal to -3. We plug in -3 in here. We get -3 plus 1, negative of -2, which is just 2. You see how this negative and this negative, they cancel out to make a positive, and that's exactly what the absolute value does. That is why we included a negative when x is less than -1. And if we also put x is equal to -3 back in the original expression, we get -3 plus 1, absolute value of -2 is just 2. So this 2 and this 2, they do match. So that's how we know that these expressions are correct for their respective domains. So now that was only this part right over here. We do have to do the other two absolute value functions. Let's start with x. So we have x. Our domains are going to be x is greater than 0 and x is less than 0. And our expressions are going to be x and -x respectively. And you can once again try this again by just substituting values greater than 0 and less than 0 and seeing if you substitute in here, if that value is actually equal to if you substitute it on the right side. And for our last absolute value, x minus 1, our critical point is going to be x equals 1. So we have two domains, x is greater than 1, x is less than 1, and our expression for each is going to be x minus 1 for the first and minus x minus 1 for the second. Now that we have this, it is time to actually start solving this. So what I'm going to do, I'm actually going to split this integral into 3 integrals. So I split this integral into 3 different integrals to make it a bit easier to solve. Now let's solve one integral at a time. So from over here, we see that this is -1 to 2 of this function right over here. Let's take a look at that piecewise function over here. And this piecewise function says when x is greater than -1, we are going to have x plus 1 as our expression. And lucky for us, the domain -1 to 2 is definitely greater than -1. So we are just going to rewrite this integral as keeping the bounds the same of x plus 1 dx. But the other ones are going to be a bit more tricky. And what I mean by that is, let's take this one for example. We have absolute value of x, so we're looking at this piecewise function right over here. This bound needs to be broken apart into two bounds. The original bound is -1 to 2, but our piecewise function slices that down in the middle because now we have a 0. We have two different functions when x is greater than 0 and when x is less than 0. So I'm going to break this apart into two inequalities. So we have -1 to 0 and 0 to 2. The reason I did this is because this is essentially this expression right over here, -x. And this expression right here, 0 to 2, is this right over here. And this is x. So I'm actually going to split this integral into two different integrals because we have two different bounds. So I'm going to split it into -1 to 0 of -x dx plus 0 to 2 of x dx. And I got that from right over here. Now for our final absolute value integral, we have x minus 1, meaning we're going to be looking at it over here. So we have -1 is less than x is less than 2. Those are our bounds. But of course, it's not going to be that simple because we see that 1 slices right down the middle of this range. So I'm going to split this range into -1 is less than x is less than 1 and 1 is less than x is less than 2. For this part over here, we are going to use the x is less than 1 part, so that one right over there. So our expression is going to be something like this. And for this part over here, that is when x is greater than 1, right? So we're going to use this expression right over here, x minus 1. And I'm going to break this integral apart into 2 different integrals. So it will look something like this. So we have -1 to 1 from over here. Expression is going to be negative x minus 1 dx, and I'm going to write our last integral down below, and that is going to be 1 to 2 from over here, and our expression is x minus 1 dx. Now let's actually go ahead and solve this. So these are pretty basic integrals. One thing I'm going to do, I see that there's a negative over here. I'm going to take that negative out, so that's going to be a negative. And I also see that there's a negative here. I'm going to take that negative out. So negative over here as well. And I think that's it for the negatives. I'm now going to start simplifying. So I have integrated everything and also rewritten those bounds. And now I'm going to start substituting these bounds. I know it's a lot of algebra, but it has to be done to get the final answer. Alright, and now let's start simplifying all of this. And after all that simplifying, we get a final answer of 19 over 2. So the main takeaway over here is to get these 3 piecewise functions so that we can apply them to our integral. And it's always important to note that even though we only had 3 integrals to begin with, we had to split 2 of these integrals into subparts because their ranges simply weren't, I guess you could say, compatible with the ranges we solved in the piecewise functions. So as a result, we did have to do a bit of algebra when it came at the end, but nothing too serious, just a few simple integrals. But yeah, that is it for this video. Thank you guys so much for watching, and I will see you guys next time.